Let us look at the modern perspective of integral calculus. In calculus, there are two main drivers: slope of a curve at a point and the area under the curve. When the focus is on the slope of a curve over its domain, it is called differential calculus. And when the focus is on the area under a curve, it is called the integral calculus. Under the curve means bounded by the x-axis and the curve. So let's look at a curve. If we are interested in the area under the curve, then this is the area that we are talking of. So here, this area is bounded by the x-axis and the curve. If the curve is above the x-axis, the area is positive. So this area and this area is positive. If it is under the x-axis, the area is negative. If it goes above and below the x-axis, then the net area is area above plus area below. So basically we sum up this. But remember, when we are summing up, these two are positive, this is negative, which means it is possible to have the net area less than or equal to 0. If we are interested in the total area under the curve, then we take the absolute values. So absolute value of the area above plus the absolute value of the area below gives us the total area. So which means total area cannot be less than 0. Now area under the curve from x equal to a to x equal to b is called definite integral. So remember, this curve, purple one, is a part of another curve whose domain has been restricted to these 2 points. Which 2 points? These 2 points, a and b, x equal to a to x equal to b. The general expression for the area is called indefinite integral. So let's briefly look at an example. Don't get bogged down with the details, just get the overall feel. Now this curve that we are looking at, the red one, is f of x equal to x cube plus 3x square plus 2. The integral of this function with respect to x is equal to x to the power of 4 by 4 plus x cube plus 2x plus c. This is called the indefinite integral. Now, how we arrived at this? For the moment, let's not get into that level of detail. But when we are talking of a definite integral, we are talking from a particular x value to a particular x value. So integral from 1 to 2 of f of x dx is equal to, take the integral expression, put a bar and write 1, 2, which means subtracting the value evaluated by substituting x by 2 minus the value obtained by substituting x by 1. So here, if we evaluate it, we arrive at 51 by 4. This is the definite integral. So which means what? Indefinite integral gives us an expression which is itself a function, whereas the definite integral gives us a value for the area under the curve. So since this integral is a function, we can also graph that. So this green one is the integral function. What does this graph indicate? It shows us the rate of change of area under the curve as we go from left to right. Now, as we go here, this is all area under the curve. This goes to infinity. So This is the area under the curve. As we move towards the right, what is happening? This curve is restricting the rate of change of area. And when we come here, what is happening? The rate of change of area again changes. Here again it changes. And as we go here, the rate of change of area keeps increasing. We'll get into all the details, and that's the fun part. Now, here, this graph could be anywhere. It would still represent the area under the curve. And that is where this C comes in. C gives us the y-intercept. Remember? So, but in every other respect, the graph is same, except the y-intercept. So, because we are not very sure of which particular graph of this family of graphs is the right one, we just mark it as C, the y-intercept. So, in other words, the graph of x to the power of 4 by 4 plus x cube plus 2x plus c will be a family of curves displaced vertically, where each member would have a specific value of c. The integral represents the area under the curve f of x equal to x cube plus 3x square plus 2. Naturally, if we want to know which particular member of the family is the right one, we require additional piece of information. So that was the modern perspective, a very brief one. And as we go along, we will actually look at how exactly this area is found. Here I'm, using GeoGebra. I'm just showing you the area, but how exactly it can be evaluated, we will look at it in the next sessions. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. If you think somebody else can also benefit from it, please do share. That's it for now. Bye.